Hi, welcome back to the Workbench. If you enjoy these videos, please give us a thumbs up, subscribe down below. Today I'm taking a look at the Tronxy X6A 3D printer. I happened to pick it up last year because it was on a smashing blowout deal for $130. It actually cost less than the item I was going to purchase, which was simply one rail for a Ender 3 printer we have over at the Makerspace. I wanted to add an extra rail for stability on it because it kind of sags on one side. It's just a feature of those printers. Doesn't impact it too much, but still irritating. So instead I got this for almost the same price as the single rail. What does it come with? A starter roll of filament, PLA, some tools, a USB cord, a bit of screws, extra screws, and the only actual assembly steps on this thing were screwing in 4 screws on each side for this steel assembly. They don't actually have much for the instructions on this. It's just a two-sided sheet with some very vague, poorly spelled instructions. They didn't explicitly tell you to put this on in any particular way. What I noticed with some of the pictures is they appeared to have zip-tied it up to the PTFE tube for the filament, so I put it on there. The unfortunate thing with this is still a huge doofy cable. So I assume what you're intended to do is just bind it up and then zip tie it onto here, which I'll do now to get it out of the way. This is kind of junky. I prefer not to have an extra meter of cable on the printer just because there's no reason for it, and now you're passing the electric over an even longer cable. So there's no reason for that. It could only cause problems. Also, as with many of these printers, the cable retention isn't great. As you can see, this is just held in place with a zip tie, and it's all kind of loose. It does move around a bit more than I'd prefer when it's rotating around on that. I might 3D print just a little piece of plastic to hold this in place better, to cup it, and then either zip tie it or have a two-piece just crimp connector that crushes the cable and holds it steadily in place, probably with a short bit going up to hold this rigidly in place, just so it's not flexing at one point overly much. That's kind of the problem I always run into with this style of printer. The heat bed cable is pretty poorly secured as well. It's just kind of jostling around in there. It does have a zip tie, which is better than nothing, but they only have one that comes pre-installed from the factory. There's a second, which you can't see, there's a second hole over here in the underplate for a zip tie. They just didn't bother to attach it to anything, so I'll also do that now. That's kind of obnoxious. I'd prefer these things came useful out of the box, because if somebody doesn't realize that they have to make sure that cables are tightly held in place on mobile platforms, they might run into a kind of horrible situation where the cable rubs and now the bed's live or sparking or whatever. It definitely wouldn't cause anything good. There we go. That's a little more secure now. That should be fine. There. I still don't really like how this is just loose and whipcording around out here. I might do the same thing down here, make a little attachment for it that just holds this rigidly out in one direction, and probably with a flexible end on it, so it'll just, the whole cable will move rather than just one point. But this should hold for now. I don't think this was hitting anything on the back, which is okay. It's actually better than some designs I've seen where the cable on the back is hitting something. One of these cables, up here. The other thing I noticed here was that this cable is well frayed out on the end for the connection. That's, I don't know, that's not great. That looks horrible. Probably looks worse than it is, but right at the flex point, being frayed all over the place like that doesn't inspire a whole lot of confidence. Actually, one of the things I can do to mitigate that a little bit until I get around to actually properly fixing this, add a second zip tie here to help hold this a little more rigidly in place. I prefer if it actually attached to the back of the plate, or the plate went up a little higher, but since that isn't the case, I'll at least add a little more rigidity to the assembly right there. And hopefully that'll move a little less. The hot end is pretty good. It's a J-head design, so it's feeding from up here over to the hot end, and the motor's over here. So you do get a lot of drip from the hot end. It tends to extrude a lot of extra plastic. I just made up some quick G-code, which I'll probably include in the comments down below, for a start code on it, so that it would extrude a bit of plastic and then wipe on the plate and then start printing. Other than that, it works okay with Cura. With one of the other Tronxy settings, I'll have to figure out which setting that is as well. Other than dripping PLA, the settings for the other Tronxy printer work just fine with this one. I just changed the size to the correct size for the bed. I might actually just make a package of that if Cura will let me do it easily enough and include it. I'm not a huge fan of the spool holder. It just kind of holds the spool almost on the ground. Not great there. That could definitely be replaced by something, or just an off printer spool. The wiring was pretty simple. There's a lot of extra cable here, which I don't like, but the wiring itself was fairly easy to hook up. It's all just labeled for the motor it goes to. I'm assuming the wiring is sufficient. I'd have to actually go ahead and look inside here to see what it's running for a power supply, see how the connectors are. I have no idea if that's sufficient. I know on some of the printers it just never is. And some of the other things I'm noticing on here is the print bed seems to be rubbing somewhere. That sounds like the belt is rubbing. That might just be that the front part needs to be adjusted so that it's lower or higher, just to make a good pair with the other side of the belt. I'm guessing it's too high on here, so that's probably got to get adjusted. The bearings could use some grease. They don't appear to have any on them. They're pretty dry sounding, although you can't really hear that much over the belt now with that rubbing. But the rods are only held in by a couple of grub screws on each side, pressure fit. Look like they've been chopped with a hacksaw, which I don't know. You could at least throw it in a vise of some sort and hack it even if you're going to do that, I guess. Or if you have 3D printers, you could just print a little piece of molding to hold it in place and give you an even line to hack on, rather than just smashing it with a saw. But whatever. The print bed is already starting to fall apart, and after 2 prints on it to see how it works, it's starting to disintegrate. The PETG didn't even stick particularly well, but already took a divot out of the middle of it. So I'll be replacing this with a PEI print sheet. It'll work better than this thing anyway. So the Zaxis rods also seem to be a little loose on here. I'm going to go ahead and tighten those, at least torque them down to the point where they're not loose anymore on here. I don't know that these have to be especially tight, but they shouldn't be loose anyway, and they were a bit wobbly on both sides. And the same for these on the motor ball screw mounts. I assume it's a ball screw or lead screw, whichever. Anyway, these were loose, so those should probably be tightened down first thing on any of the printers that you're working on. Otherwise, you'll probably have a bunch of rattle on here. I was getting. That's how I noticed it in the first place. I forgot to check these straight off, but the oh yeah, that is not actually screwed in at all. So these are incredibly loose, and I was getting quite a bit of rattle on these, so that's something you'd want to check. And I have no idea how tight they're supposed to be, because there's no real guide to any of this, but I'm just tightening them down to the point where they're not loose anymore. Figure that'll probably be good enough for this. Yeah, and those are actually tight on this side. They were a little looser on the other side, so. The Y-axis belt mount might also need some correction. It tightens up the belt enough, but the belt seems to be catching somewhere. I'm hearing a little bit of, I don't know if you can hear that or not, but at a few points the belt's making a catching noise on something. All right, there still seems to be some problems there, so I'm going to install this piece, which is a longer piece than the original. It's just a deeper well for that back piece to sit on, and we'll see if that gets rid of the problem. If I'm able to then tighten it up and tension it properly and have the belt feed somewhere in the middle on it rather than wobbling off to one side or the other. 1 second. There's the two Y-axis belts for retainers for comparison. This one's the new one. It's a bit deeper, as you can see. The old one's a bit narrower. Shallower, I should say. Alright, I don't hear that belt rubbing anymore, so I think this replacement part, I'll link to it down below on Thingiverse, probably worthwhile. With a bit of adjustment on the front for the height, and putting this in place, and then tensioning it properly. The belt tension seems good, and it doesn't seem to rub anymore back here on the tensioner. So, that's a worthwhile replacement. It seems to actually hold it in place a little better. I did manage to find some Shitubox mainboard settings that I'll link to in here. It looks like the forbidding temperature error detection is probably turning off the safety features for over-under temp and to see if the thermistors got unplugged. It's M8023 space T0 to enable temperature error detection. And then to save that off, it's an additional M8500. So that's probably the most important one in here. There's also the PID settings and things like steps per millimeter. Although the responses this thing gets back aren't great, and you don't really have any idea whether it's turning them on or off. You'd have to go and physically check one of the thermistors, unplug it on the board. It doesn't use the standard M503 or any of the standard Marlin, G-code, Repetier settings as far as talking to the printer goes. They have their own M8 4-digit codes. And there's a few more things to note on this printer. So the menu system doesn't give you too much control. It apparently has a somewhat beta firmware on it that's unreplaceable, because I looked up Tronxy's site, I looked up the Alfawise, I think is the brand name of Go something. Anyway, one of the third-party resellers resold these as well. Neither Tronxy nor they have any kind of updates for this, or even the original firmware is available, so there's nothing at all. In a separate video, I'll have to take apart the electronics on this and see if there's anything you can install on them or replace them with that would give you any ability to make sure that this thing has thermal controls turned on or whatever. I'm not sure what it's running on it. If it's Marlin, maybe you can replace it with a stock Marlin setup. Although this UE toolkit, unless this is totally separate, you'd probably end up losing the screen display, even if that's possible. The design itself seems to be a clone of the Anycubic i3 Mega or Mega S printer. I'm not sure if any of that's compatible, so that's also something I'll look into to see if they use any similar electronic setup. Maybe the firmware off that will be usable for this, or third-party firmwares that people have developed, if there are any available. I'll do a couple of test prints and we can see exactly how well it prints. I'll get a couple of prints printed out and take a look at those quick before I wrap this up, just so you can see what kind of quality this thing gets. It looks like it should be pretty good if I can get it to actually start printing accurately, and probably I'll need to replace this sticker on the bed because that's already blowing apart just from use. Other than that, I don't really have too many complaints on that aside from what I've noted. Oh, and the bearings probably should get greased as well on this axis. Those are not lubricated with anything, so I'll probably put some white lithium grease on them, or if I've got anything better, maybe some molybdenum. I really need to figure out a better grease for the bearings on these 3D printers, something appropriate and maybe a little more sticky than the white lithium grease I've been using up till now. I'm going to go get this printing, and we'll take a look at that in a few minutes. While that print's going on, there's a few specifications I forgot to mention on the Tronxy X6A printer. The print bed's 220 millimeters square. That compares to, say, the Prusa i3 Mark III's 250 millimeter deep by 210 wide, and I believe 210 high as well. The print bed itself is kind of junky. It's got a peel-off sheet on it that doesn't work very well. Whatever plastic they chose to use isn't nearly as effective as PEI. Also, it started peeling up and the color was coming off on prints, and it just overall not very good. What I'll be doing is replacing it with a spring steel PEI sheet that's magnetically held to the bed. Look forward to that in an upcoming video. The inductive bed height sensor might actually work a little better with steel. It did seem to work okay. The firmware is a bit strange with the inductive bed height. One of the things you have to remember in this model is that when you set the inductive bed height automatically, you actually want to go ahead and do the Z offset right afterwards. It doesn't make that apparent. Also, you want to set the bed height with the screws underneath so that it's roughly flush across the entire surface. That's not obvious from there either why you'd use the automatic setting versus using the manual setting. That'd be why. You want to make sure that the bed is just about level and then let the bed mesh sensor do its thing and create a map of it. I'm not sure if it's doing an initial map of just the first layer or if it's offsetting your entire print based on that map. It's unclear from there, and it wasn't really clear from printing either. It did seem to work okay though, so I assume the adjustments are fine for what it's doing. The filament out sensor worked okay. I did have a situation where the filament ran out and it stopped. One thing to remember on here is that it will stop indefinitely. It doesn't time out after a set period, so it'll just sit there running the hot end and the heat bed until you come back and restore it. The 12 volt DC system works okay on here. The hot end and the heat bed worked okay to heat up the plate. There isn't too much time involved in waiting for them to heat, so it's effective. The processor board for the system's a Shitu-based board, apparently produced by Tronxy. It's marked by Tronxy. The wiring inside and the power supply are a bit suspect. I'll be replacing those in a future video on repairing your 3D printer and making improvements to it in general. I'll be doing the connections and the power supply, and we'll take a look inside it then. Also in an upcoming video, I'll be replacing the firmware on the Shitu-based board, hopefully with Marlin, but we'll see what I can wedge on there. There are actually a few more features available on this board as well, such as lighting and an additional extruder. So you could hook up lights to either light the print in particular or to light up the printer in general when it's in use. That might be nice for some applications. Let's see how the print turned out. And done. All right. This was the Mandalorian Pose 3. I'll link to it down below. Done at 60% size. So I didn't expect it to get any of the fine detail quite right on here, but if you take a look, that came out pretty good. I'm happy with that. The overhangs are okay. A little bit chewed up, but nothing to complain about. The fine detail got a little squidgy. So you can see there's something going on there, probably with the amount of extrusion, because some of the outer layers, like this, let's see, some of the outer layers like that got completely missed, and I don't think it quite handled all of the areas okay. It looks like there was under extrusion in spots. I'm guessing probably flow rate on the nozzle, although that could also be the slicer settings, because I'm not sure that it's set up properly. There weren't any actual slicer settings for this, so I can't really say whether it's currently quite right or not. I'll leave my settings included here, but I don't know if they're right. Maybe somebody else can chime in with some better ones, hopefully. And that's it. Came out okay. I also did a benchy. The benchy was somewhat more successful. Also, some of the same problems. If you look up here on the stack, it actually has an area where it's chewed out again. So, some of the same type of things going on there. but overall, pretty good. One of the problems I came up with on this that I'll note now, so because I had to bind up the PTFE tube here to help support the wire to make sure that it doesn't flex itself to death when the thing's moving around. This was actually, the PTFE tube actually turned out to be much harder to put in here than I anticipated. It didn't like going in all the way. I think it was riding up a little bit, which is what caused me to have some problems like this. And it blobbed up inside there and was just not extruding. Once I moved the PTFE tube down all the way, it stopped doing that. I think pretty reliably. I'll play around with it a little bit more and leave a comment if I didn't solve that problem. I'll have to come up with a video to address some of the problems with this. There's a bunch of smaller issues and a few probably major ones with the firmware that I'll see what the actual problems are, and I'll try to address them. One of the things I did was just provide a piece of tape here. This hot end needs to be laid out a little better so that the cold end fan wouldn't be cooling down the hot end. It was just blowing on both of them, and I put a piece of tape to block the air path from the fan to the hot end, just so the hot end wouldn't be getting cooled when it shouldn't be. And that's about it for the Tronxy X6A. Hope you enjoyed the video, and we'll see you next time.